Indiana University East Chemistry C105, using heats of formation to calculate reaction enthalpies. The thing about documenting enthalpies of reaction is that there's a huge array of reactions, and there are different reaction conditions that we can have. Different temperatures, different pressures, and so on and so forth. We can rectify the second one relatively easily. We will define as our standard conditions to be 25 degrees centigrade and 1 atmosphere. However, the difficulty remains in that there are no absolute enthalpies. How do we deal with this? We define instead something called the heat of formation. The heat of formation is the enthalpy change associated with forming 1 mole of product from its constituent elements in their reference states. What do I mean by reference state? The reference state of a particular substance is its most stable form. So for example, bromine's reference state is a liquid, while copper would be the solid. Oxygen would be gas. In an exam, I would just expect you to know the ones that are common sense or common knowledge. The only exception is carbon. The reference state of carbon is graphite. It can be deduced from the definition that elements in their reference state have heat of formation of 0. Let's take a couple of examples. The heat of formation of nitrogen dioxide gas is the same as the reaction enthalpy for the reaction of half a mole of nitrogen gas with 1 mole of oxygen gas to form nitrogen dioxide. You should note that you always are forming 1 mole of product. And to do that, you will sometimes have fractional numbers of moles of reactants. Another example is the heat of formation of carbon dioxide. That would be the reaction enthalpy for graphite reacting with oxygen gas to form carbon dioxide gas. Now that we have heats of formation, it can be shown using Hess's law that the heat of reaction is the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. Of course, taking into account their stoichiometric coefficients. For example, let's consider the reaction of nitrogen dioxide reacting to form dinitrogen tetroxide. The heat of reaction is given by the heat of formation of dinitrogen tetroxide gas minus 2 times the heat of formation of nitrogen dioxide gas. And I can look these numbers up in a reference work or in the back of your textbook, and I find that it is minus 57.2 kilojoules.